In this video, we're going to do a slightly more difficult example of dealing with, in this case, products. But it's the same idea as could be used with summations. Summations and products work very similarly to one another. The only difference is multiplication versus addition. So here we've got two products that we want to combine and simplify, but we've got a problem because in this first product, if you look at the bounds, we've got n plus 2 minus 2 equals n elements. And in this product, we have n minus 1 elements. So this product right here has one more element than the other one. And so no matter how we change the bounds, that's not going to work, right? If I go down so that its numerator is n, then we're going to go down to 0 at the bottom. And over here we have n and 1. So we've got a problem. The way we're going to need to deal with this is we're going to need to both do a change of variable, and firstly, we need to pull an element off of this product to make these two products have the same number of terms. So that's the first thing I'm going to do. So we're going to have to simplify. I can take either the first term off of this or the last term. If I take the first term, notice it already starts at 2. So if we were to expand this, actually, let's do it this way. This would be 2 minus 3 times 3 minus 3 times 4 minus 3 all the way up to n minus 3, n minus 1, or excuse me, n plus 1 plus 3 minus 3. N plus 2 minus 3, right? If I take this first term off, then we're going to be starting at 3 to n plus 2. And if I take this last term off, we'll be starting at 2 to n plus 1. In either case, we're going to have to still do a change of variables. So it doesn't really matter which one we pick. You can pick either of them. I'm going to take the last term off for no particularly good reason. As I said, you can do it either way. And a good exercise would be to try it by taking the first term off on your own and verifying that you get the same answer or an equivalent answer. Okay, so I'm going to rewrite this first term. In terms of pulling that last term off. So again, we can expand it quickly to help visualize. 2 minus 3, 3 minus 3, all the way up to n minus 3, n plus 1 minus 3, and n plus 2 minus 3. Right? You can combine these in little parentheses if you want. So this is the last term that I'm going to remove, and I want to rewrite this as a product. So that is going to be, well, we still start at 2, and now I'm ending at n plus 1 of k minus 3. And I need to make sure I multiply that whole thing by this term. I'm going to simplify it so it's n plus 2 minus 3 is the same as n minus 1. Okay, so we've pulled that last term out, which means I can rewrite my original problem as I'm going to use this replacement to go right there, but I'm going to reorder it slightly. So I'm going to put this n minus 1 part first, and then k equals 2 of n plus 1 of k minus 3 times, and this one is from I equals 1 to n of I squared. So we still have bounds that don't match. So what we're going to do is we're going to need to do a change of variable on this guy right there. So I'm going to pull that out. We have k equals 2 to n plus 1, k minus 3. And what transformation do we want to do? Well, I notice that I want to put it in terms of I equals 1, but I have k minus 2. So what I can do is I can say, I'm going to do this up in this upper right corner, let I equal k minus 1. And notice k minus 1 will take that 2 down to a 1, which is what we're trying to do right there. And likewise, if I is k minus 1, then k is going to be I plus 1. So I always put both of them down. There we go. And so now we're ready to start working with the bounds. So the lower bound we currently have k equals 2. Well, using this equation right here, I can get what I is equal to 2 minus 1, which is 1. So I equals 1 is our lower bound. And our upper bound, we're going to get k. Well, k is n plus 1. So once again, I'm going to use this first equation. And I'm going to transform this. Using my equation for I. So we have I is equal to n. Right. And now we need to do our body. Let's keep this separate here. Body, we had k minus 3. Now I'm going to use this variable. I could use either one. So both of those variables, or both of those equations, are useful. What I want is I want to get this body in terms of I. So what I'm going to do is I'm going to say, well, if k is I plus 1, then this is going to be I plus 1 minus 3, or I minus 2. Okay. And again, we can do our check that we went down on our bounds, so we should go up in the body. And even though it doesn't, we're still subtracting, we're subtracting less than we did before. So that all holds. That all works. Okay, so now we have our new value that we're going to substitute in. And I'm going to do this on the next page. So I'm going to rewrite this whole thing on the next page. Okay, so we've got that this is equal to n minus 1 times the product, k equals 2, to n plus 1 of k minus 3 times the product I equals 1 to n of I squared. And now I'm going to make that substitution, and this is going to be n minus 1 times the product I equals 1 to n of I minus 2 times the product I equals 1 to n of I squared. And now, so this is by substitution. Now we can use that first property of products to combine these, because finally the bounds are the same. And if we simplify this further, we're going to get I cubed minus 2I squared. So this is definitely a more difficult problem, but as long as you just take things step by step, it worked out. So the first thing we did is we pulled a term off of the product that had one too many terms in it. Then we did a change of variable to make sure both products have the same bounds. And then finally we combined them using our, actually it's this one, using our rules of products. And then of course we just simplified.